All right, section 6.3, separation of variables is going to feel like it's just the same thing we've been doing. There's not going to be a lot of differences. There's going to be some nuances, a little bit of different changes on how to separate these variables and so forth, but it's going to feel a lot like what we've been doing. And so first, let's actually define what it means for it to be a separable function. So separable means these are equations of the type where we're able to separate all the x variables on one side with all the y variables on the other side. Okay. Sounds just like what it is, right? We're able to separate them. Sometimes that ends up meaning that we have some logs come about, right? We've got some division going on. Sometimes we have some addition and subtraction that shift things around. And a lot of times they give us things that have a y prime in them, and we start out by writing them as dy dx, okay? So those are the kinds of things that we've been looking at anyway, and we're just going to continue looking at those kinds of features. And remember, in chapter 6, we haven't gotten to chapter 8, which means the only tools you have are algebra and trig simplification and use substitution. So none of our fancy techniques with partial fractions or integration by parts, none of that is present here, right? This is all the stuff that happened before then. So we'll take a look at an example. We have the square root of x squared minus 16 times y prime equals 11y. And the first thing that we're going to do when we start this is we're going to rewrite the y prime as dy dx. Okay, everybody good with that? Okay, so on the right-hand side, I've already got x's and I don't have any y's. So shifting all the things with x's over to that side seems like a reasonable thing to do. Yeah? So everything on the left that has x's in it, which includes the square root and it includes the dx, can move to the other side using inverse operations. So the dx will be multiplied, and what will we do with the square root? We'll divide. Okay? So we're going to rewrite this as dy on the left, and then the square root gets divided, and then the dx gets multiplied. This is the separation process. Everything with variable y is on the left, everything with the variable x is on the right. And then we're able to take antiderivatives. Now the antiderivative on the left is very straightforward. What's the antiderivative of dy? Y. And then what we'll have to do on the right-hand side? I might try trig, but actually use substitution works really well on this one. If the numerator had addition or subtraction in it, it wouldn't. But because the numerator is a single term, it works really nicely. So my u would be what? Yeah, the part that's underneath the square root, the x squared minus 16. And then what would du be? 2x dx. Now, I don't have a 2 in my problem, but constants are irrelevant. We can just shift those at will, right? So we can divide by 2. And the 11 will get grouped with the 2. So I'll put my 11 and my 2 out front, like that. The part that I've circled is now the du part. And then I have already in a couple steps, this is 1 over the square root of u, right? Now, it's not a very friendly form for taking an antiderivative, so whether it's in this step or this step afterwards, I'm going to rewrite this as u to the negative 1/2. Is that good? Okay, then. What is the antiderivative of u to the 1/2? I'm sorry, u to the negative 1/2 is what I meant to say. It'll be u to the 1/2, and then what? Yeah, divided by 1/2 or times 2, right? And we need to remember that we need a plus c, okay? We can't stop there for at least 3 reasons. So somebody tell me one of them. 2's will cancel. We don't have x's, so let me fix them one at a time from what you're saying. So I can replace this now as 11, and it will be the x squared minus 16 to the 1/2. And there's one more thing that I need to change. Yeah, I don't want the fractional exponents. It's not so much that I can't have them, it's just that they weren't there originally, so they're not going to be there in the answer, right? So my final thing that I would want to adjust, and you could adjust all of these at the same time, of course, is to rewrite this as such. Okay. Does it feel like what we've been doing? It feels a lot like what we've been doing, right? Not much different going on. How about the directions on number 2? What does it mean to find a particular solution?
Plug in values.
Plug in values for what purpose? To find the C value, exactly. Particular solutions mean that at the very end, I'm going to figure out what C is.
Like definite integrals.
Yep, kind of like definite integrals. I'm going to get a number at the end. My C is not going to be there at the end. I'm going to get a number for C at the end. Yeah.
C. Nobody likes to see.
Yeah. Nobody likes to see. Okay, so the first thing we do is going to look like what we just did before, though, right? We're going to do all the same process. We're going to get the plus C, and then we're going to take that one step at the end. So what will I do first, looking at this problem? Okay, we can do that. We can move our natural log of x squared to the other side. Sure. What might we do next?
The x over there.
Okay, we can move our x over there. So I can leave this like so. Change the y prime. Okay, and if you're looking at this and you're like, well, I would have done it in a different order. There's lots of orders. That's okay. Everything we're doing right now has sort of independent of the step we're on, right? So this is dy dx. Okay. Something else. The dx needs to move. And it's going to actually be really nice if I move the 2 with the x. So I'm going to do that and put the 2 over here as well, just because of a simplification step that I know that's coming up. If you'd left the 2, it would have been fine. Eventually, it would have simplified out as well. So natural log x squared over 2x dx. Okay, now what?
Great.
So there's something I'd like to do before we integrate. Thank you, Jackson. Okay, this happened on your test, right? Y'all know what I'm talking about? I think problem 6, right? Where it had a natural log of x to the power 4. Powers are much more difficult than constant multipliers. Constant multipliers are very friendly, easy to work with. Powers are generally not quite so friendly. So it will be lots nicer here. It's not the only way to do it, but it will be a lot nicer if I actually bring the 2 down. And then do you see why I wanted to move my 2 with my x? Yeah. So the 2's will cancel here, right? Okay, so we are at the point now, I'll rewrite it up here so I have a little bit more space, where I can take my antiderivative very nicely. So natural log of x over x dx. All right, left-hand side. Why? What do I have to do on the right? What's that? U sub. What would u be, Sophia? Natural log of x. Okay, because what's du of the natural log of x? 1 over x dx, and we actually have that, don't we? This piece right here is the du. So that's actually quite friendly. So we have the integral of u du. So then, what is the integral of u? U squared over 2 plus c. Okay, then put the u back in as natural log of x. So natural log, and we can write the 1/2 in front if you don't want to write it as over 2. Either one's fine. Natural log of x, quantity squared, plus c. We can't move the 1/2 in front here, right? Because our whole natural log is squared. It's not just the natural log of x where x is squared. So I can't simplify the expression. It really is in its simplest form. But I'm not supposed to be finding an answer with c at the end, right? So what do I have to do next? Yeah, they give us a piece of information that we get to use. They tell us that when x is 1, y is 2. Right? That's what this statement means. When x is 1, y is 2. So I can take the 2 and put it in for y, and I can put the 1 in for x. Like so. All right, so what is the natural log of 1? That's 0. So everything over here except for the c is actually equal to 0, right? So what's c? C is 2. So then my final answer, which I'm out of space to write, so let me shrink this all a little bit. My final answer for this would be that my y is equal to 1/2 natural log of x squared and then plus 2. Okay, all good? Okay, read the directions on number 3.
Isn't this the same thing?
Ooh, it is. Directions kind of sound like it's different, right? Did everybody see that? This is the same question we did before. It's just phrased differently. Yeah? Okay, so let's give it a go. We have this over here to start with. What shall we do first? What's that? dy dx. And it's supposed to equal y over 2x. Okay, now what? Okay, so divide by y. So I'm going to move the y to the left. I'm going to write it as multiplication of 1 over y. Anything else? Maybe I could do in the same step. Maybe not. We'll just rewrite it like this. There we go. Okay, so I've got all the y's on the left now, but I need the x to be moved. So I'm going to multiply by dx on the right and the left, right? So it looks a little bit funny because of the multiplication and division that we're doing, but it's not any different than what we have been doing. So 1/2 dy dx equals, and then I've got 1 over 2x dx. Okay, have we separated everything? Yeah, it's all separated now, right? So what's our next step? Integrate. Now this is the most interesting integral on the left-hand side that we've had thus far today. What's the antiderivative of 1 over y dy? Okay, so natural log of technically the absolute value of y, right? And there's a plus c going to be somewhere, but we can collapse them somewhere, so we might as well just put it on the right-hand side. So I'm not going to put the plus c for now. I'm going to leave it where it is, just absolute value y. On the left-hand side, what can I do? Okay, so it's going to have a natural log in it. It could be u substitution. There's actually an easier way even to do it than u substitution. You could put the 1/2 on the outside. So u substitution would be perfectly fine. You can do it that way. The u would be the 2x in the denominator. But because this one is so clean, it's also easy enough to just pull the 1/2 out in front. So my suggestion would be for us to separate it in that order. Hang on. Move this over here. So we can put our 1/2 out in front, and then I can just make this a 1 over x inside. If you do use substitution, you'll get the same thing, obviously. So I have 1/2, and then I have the natural log of the absolute value of x. And I do need a plus c on one side or the other, so I'm going to put it here. Okay, everybody good so far? Okay, so I need this to be solved for y. Like it needs to say y equals. We've seen this. We saw this in a previous section. What would we do next? Yeah, so we're going to put e as the base on both of the sides. What happens on the left-hand side when we have e natural log? It's just what? It's just going to be the y. Okay, so we have y on the left. What's going to happen on the right? It's really messy the way it's currently written. We need to make a little bit of some adjustments here to be able to deal with and cancel some things like we just did on the left. Okay, so that's one of them. So Braden noticed that there's a 1/2 in front of the natural log of x. We can pull that up, so that's helpful. So I'm going to write that as e to the natural log of the square root of x, right? That's what the 1/2 power would be. Okay, the other thing that I can do is that I can separate the e to the c here. And I'm going to go back and I'm going to call it C1 at this point because this is what we learned back in, I think it was section 2. Then we have the e to the C1. That's just a different constant, which we'll call c. So coming up here, let's come over here. Now I've got...
Do we have to do that, Steph? Or
You don't.
Just bring it up?
You can just bring it out front as a c. That's fine, yeah. So there's a c, and then I have e. Well, actually, let me pause. What's going to happen to my e to the natural log of square root of x now? That's just square root of x. So this is what we have right now. So y equals c squared root of x. And if we were finding a general solution, we would be done, right? But we're not. What are we told? We have a point. Yeah. So, and it's a very nice point, actually. It's very friendly. When x is 3, y is 9. I think that's what it says, right? Did I get that right in my mind? Nope. Different question. When x is 9, y is 1. So x is 9, and y is 1. So what will c be? 1/3. All right, square root of 9 is 3, divided the other side is a 3, 1/3. And so we have y equals 1/3 square root of x. Okay, everybody good? All right.